Okay, the next word problem. So the rate at which an organism duplicates is called its doubling period. The general equation is, so we've got an equation here. It looks very, very similar to what we just used. So very similar to our y equals a, b, x. And we actually split this into our t over x here. So don't worry, it's basically the same thing. But here they're already telling us what the base is, which is nice. Where n is the number present after time t, and O is the original number, and D is the doubling period. So again, pretty much the same. E. coli is a rod-shaped bacterium commonly found in the intestinal tract of warm-blooded animals. Some strains of E. coli can cause serious food poisoning in humans. Suppose a biologist originally estimates the number of E. coli bacteria in the culture to be 1,000. After 90 minutes, the estimated count is 19,500. What is the doubling period of the E. coli bacteria to the nearest minutes? Now, whenever I see minutes, it always makes me a little bit nervous because I'm so used to working in hours. But everything is actually in minutes. So that would be the first check I would do. Now, the total number of bacteria we have, so that's our N of T, is going to be 19,500. It says that we start with 1,000 bacteria. And we've got our doubling period. And it says that we leave them for 90 minutes. So that's going to be our T. So then we want to find out what the doubling period actually is. So it's very, very similar to our last question. I'm going to divide both sides by 1,000 first, though. I think that's the easiest thing. So I'm going to get 19.5 equals 2 to the power of 90 over d. And then I'm going to take the logarithm of both sides. So log 19.5 equals log 2, 90 over d. I'm going to use my power rule. So that'll become my coefficient. So 90 over d times log 2. Because it's multiplication now, I can divide both sides by log 2. So I get log 19.5 is equal to log 2. And that's equal to 90 over d. There's lots of ways to solve for d at this point, but I see two fractions that are equal to each other. What I'm looking for is in the denominator. So I can actually just reciprocate both sides. So I'm going to be left with log 2 over log 19.5 equals d over 90. Then I'm going to multiply both sides by 90. So I get 90 times log 2 over log 19.5 equals d. So therefore, to the nearest minute, we find that d is equal to 21 minutes. All right, our last word problem and last question of the unit. The formula A equals A subscript 0 times 1 plus I to the power of n may be used to solve many problems which involve exponential growth or decay, where A is equal to the amount of n time periods, AO is equal to the initial amount, and I is the percent increase or decrease. So Barbara invests $8,000 to an account which pays interest at a rate of 6% annum compounded semi-annually. So how much money will Barbara have after 5 years? Okay, so we're looking for A in this case. We're told that she starts with $8,000. And this is where it gets a little bit tricky. This 6%, when we're looking inside of our equation here, or our formula, it's how much it gets every time it's compounded. But this says semi-annually, meaning it's happening 2 times. Which means our interest rate is actually half the amount each time. So we're going to take that and divide it by 2. And we get 3% each time, or 0.03. Then we have to ask ourselves, well, how many times in 5 years will I actually have this happen? Well, it's going to happen 10 times. Because we got every year, twice a year, for 5 years. And then we can just put that right into a calculator, get our answer, and we find out that it's $10,751 after 5 years. So not a bad little chunk of change, how much she's made there. But then the question is, well, how long would it take for investment to triple then? So we're going to use the same formula. So we'll say that we want to triple her original amount. Now her original amount was $8,000, so I'm going to go 3 times 8,000. And her original amount was 8,000. Everything else stays the same. I'll write this as 1.3 1.03. And we're looking now for x. Now, I want to know how many years though. So rather than just put x, I'm going to put 2 times x because I know every year it's happening twice. Now to start solving this, I would simplify as much as possible before doing anything else, like taking a logarithm of each side. I'll divide each side by 8,000. So I get 3 equals 1.032x. Then I'll take the log of both sides. So I get log 3 is equal to log 1.032x. Then I'll use our power rule to turn that into the coefficient. So log 3 equals 2x times log 1.03. And then I'm going to divide both sides by 2 log 1.03. It's all multiplication here, so the order doesn't matter. So I'm allowed to do that all in one step. So we get 2 log 1.03 equals to x. And we find that it was 18.58 years. Now you have a little bit cautious. If it's only happening twice a year, it looks like it would have to happen, if it happened directly in the middle where she got compounded, you would assume she'd have to actually get all the way into the next year, and so into year 19, when she'd actually have it triple. If we're just looking at the interest is only added twice a year.